Hello, fellow explorers of the cosmos. Welcome back to Deep Dive, the podcast where we navigate the intricate and fascinating waters of the universe's greatest mysteries. I'm Amy, your host, and today we're venturing into the quantum realm to unravel a concept that's as intriguing as it is mind-boggling: ER equals EPR. Now, you might be wondering, what's with the alphabet soup? ER equals EPR is a groundbreaking proposal that bridges two of the most enigmatic ideas in physics: wormholes and quantum entanglement. Imagine connecting the dots between the fabric of spacetime and the invisible threads that tie particles together across the universe. But that's just the tip of the cosmic iceberg. We'll ponder some profound questions. Could the universe itself be considered a living entity, woven together by quantum connections? Is the cosmic expansion a form of growth, and might the universe face an eventual decline, much like living organisms do? Could the quantum entanglement that binds the universe link the most monumental events to the most mundane ones, like a supernova explosion to someone flushing a toilet? So, buckle up. We're about to embark on a journey that stretches from the tiniest particles to the grandest scales of the cosmos. Let's set the stage by traveling back to 1935, a pivotal year in the annals of physics. Albert Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, published a paper highlighting what they perceived as a paradox in quantum mechanics. This became famously known as the EPR paradox. They challenged the notion of quantum entanglement, the idea that two particles could become linked and instantaneously affect each other, regardless of the distance separating them. Einstein was skeptical, dubbing it spooky action at a distance, because it seemed to violate the principle of local realism. Simultaneously, Einstein and Rosen introduced another fascinating concept: the Einstein-Rosen bridge, or what we colloquially call a wormhole. This is a hypothetical tunnel connecting two disparate points in spacetime, potentially allowing for shortcuts across the cosmos. At the time, these two ideas, quantum entanglement and wormholes, were considered entirely separate, residing in different realms of physics. Fast forward to 2013. When physicists Juan Maldacena and Leonard Susskind proposed a revolutionary idea: ER equals EPR. They suggested that Einstein-Rosen bridges, ER, and Einstein-Podolsky-Rosen entanglement, EPR, are not just related, they are, in a profound way, the same thing. This bold conjecture implies that entangled particles are connected by microscopic wormholes. It's as if the universe uses these quantum threads to stitch together the fabric of reality. So, how does this ER equals EPR equivalence actually work? Imagine two particles that become entangled, a process where their properties become linked such that the state of one instantly influences the state of the other, no matter how far apart they are. In classical terms, this seems impossible. But quantum mechanics embraces this non-locality. Now, picture a wormhole, a bridge through spacetime that connects two locations. In the ER equals EPR framework, when two particles become entangled, it's as if a tiny, non-traversable wormhole forms between them. This wormhole doesn't allow matter or information to travel through it in the classical sense, but it represents a direct connection in the quantum realm. Think of it like two people sharing a secret language across vast distances. They can't send messages through conventional means, but their shared understanding keeps them in sync. In the same way, the wormhole is a metaphorical tunnel that signifies the entanglement connection. This idea suggests that spacetime geometry and quantum entanglement are intimately connected. The fabric of spacetime might be fundamentally woven from these quantum threads, meaning that the structure of the universe at the largest scales is tied to the quantum interactions at the tiniest scales. Now, let's entertain a captivating metaphor, envisioning the universe as a living organism. Just as our bodies are composed of trillions of cells connected through networks of nerves and blood vessels, could the universe be composed of countless particles interconnected by quantum entanglement? In this analogy, entanglement acts like the nervous system of the cosmos, transmitting signals instantaneously across vast distances. These connections maintain the coherence and unity of the universe, much like how our nervous system coordinates our body's functions. This perspective invites us to consider the universe not as a cold, inanimate expanse but as a dynamic, interconnected whole. It's not alive in the biological sense, but it exhibits properties of organization, complexity, and self-regulation that we associate with living systems. Furthermore, just as organisms grow and develop, the universe has been expanding and evolving since the Big Bang. This expansion isn't merely objects moving apart in space, it's space itself stretching and creating more room, a process that might be akin to growth. Turning our gaze to the cosmos at large, we observe that the universe is not static but is continuously expanding. Galaxies are moving away from each other, a phenomenon first observed by Edwin Hubble in the 1920s. This expansion is driven by what we call dark energy, a mysterious force that makes up about 68% of the universe's total energy content. If we draw parallels to living organisms, we might think of this expansion as a form of growth or development. The universe has undergone different ages, from the radiation-dominated era to the matter-dominated era, and now into the dark energy-dominated era. As for the future, cosmologists have proposed several scenarios. 1. The Big Freeze. The universe continues to expand forever, stars burn out, and entropy reaches a maximum, leading to a cold, dark, and dilute cosmos. 2. The Big Crunch. The expansion could halt and reverse, causing the universe to collapse back into a hot, dense state, potentially leading to a new Big Bang. 3. The Big Rip. Dark energy could become so dominant that it tears apart galaxies, stars, planets, and eventually space-time itself. Each of these scenarios mirrors, in a way, the aging process and eventual end that living organisms face. It's a humbling reminder of the transient nature of everything, from the smallest life forms to the universe itself. Now, let's weave back to quantum entanglement and consider its role in the grand tapestry of the cosmos. If entanglement is ubiquitous, as some interpretations of quantum mechanics suggest, then every particle might be part of a vast, interconnected web. This raises an intriguing question: could events of vastly different scales be connected through entanglement? For example, could the explosion of a distant supernova be entangled, in some abstract way, with the mundane act of flushing a toilet on Earth? While this is a whimsical thought, the metaphor serves to illustrate a deeper point. The universe is a complex system where local actions can have non-local consequences, and understanding one part often requires considering the whole. In the realm of quantum mechanics, entanglement challenges our classical notions of separateness and locality, hinting at a universe where everything is, at some fundamental level, connected. As we navigate these profound ideas, we're reminded of our own place in the cosmos. We're not just passive observers but active participants in a universe that is dynamic and interconnected. The atoms in our bodies were forged in the hearts of stars, and the forces that govern subatomic particles also shape galaxies. The ER equals EPR conjecture invites us to reconsider the boundaries between space, time, and quantum mechanics. It suggests that entanglement isn't just a peculiar quantum phenomenon but a fundamental aspect of spacetime itself. Ultimately, exploring concepts like ER equals EPR pushes the boundaries of our understanding and inspires us to ask new questions. There's still so much to learn about the cosmos and our connection to it. To wrap everything up, I like to say thank you all for joining me on this journey through the quantum and cosmic realms. If you enjoyed this exploration, don't forget to like, subscribe, and share it with fellow curious minds. Your support helps us dive deeper into the wonders of the universe. Until next time, stay curious, keep exploring, and never stop reaching for the stars. This is Amy, signing off.